These are big questions. These obviously, stack onto each other. Sorry. Oh yeah, you're passing your homework forwards. You guys are the best. Self-sufficient at this point, Mrs. Grisanti, and we love it. This can't be all. Oh yeah, it's not. Cameron, whenever you grab those from Nate, you mind just stacking them on that pile. All right. 6-pointer. Speed of a tidal wave, S, in hundreds of miles per hour can be modeled by this equation, where t represents the time from its origin in hours. So I would always go back and read that again and make sure I understand what the variable stands for. We have an S and a t. S is the speed of the tidal wave. T is the time from its origin in hours, so time in hours. Algebraically determine when the time when S is 0. So you're just plugging in S of 0. And solving. So before we jump into solving, what kind of equation is this? Is it linear? Is it quadratic? ... What's that symbol there? Radical. You've got a variable under a radical. It's a radical initially here. So radicals, you have to isolate the radical. So add that 2t over. Subtract the 6 over. So we get 2t minus 6 equals root t. Once that radical's all by itself, how do we get it out of the radical? Square both sides. Did you say square root, Jordan? Did you mean square? Okay, good. So we square both sides. On the left side, you have to FOIL, right? To square a binomial, you get 4t squared minus 12t minus another 12t plus a 36 equals t. And this is common with radicals, rationals. Anything that's not linear or quadratic to start becomes linear or quadratic. So what is this now? Quadratic. So we're going to subtract this t over to get it equal to 0. So we have 4t squared minus 25t plus 36 equals 0. We could solve it by the quadratic formula. We could solve it by factoring, but it does say algebraically, so we got to do one of those. Now, is it factorable? Guessing and checking might be tough here because you've got 4t squared, so that could be 2t and 2t, or it could be 1t and 4t. So you'd have that option. The quadratic formula isn't ideal because you're going to have humongous numbers, so that's obviously a risk. I'm just going to take this as an opportunity to review splitting the middle term, where you look for two numbers that multiply to get 4 times 36. 4 times 36 is 144. So numbers that multiply to get 144 that combine to get negative 25. So you've got 1 times 144, 2 and 72, 3 and, tell me if you see a combo that's going to make 25. 4 and 36. 5 doesn't go in, 6 and 24. 7 does not go in, 8 and 18. 9 and 16. See how my gap is closing? There's a lot of factors of 144. Like 1 and 144 are very far apart, and then it starts pinching in. I'm at 9 and 16. 10 doesn't go in. 11 doesn't go in, does it? 12 and 12. And then that gap is entirely closed. So I know I've hit all the factors. What's my 25 combo? 9 and 16. So once you find those two magic numbers, you use those to split the middle term. They're both negative, though, yes? That'll still multiply to get my positive 144, but those will make negative 25. So I use those to split up the negative 25. And I factor by grouping. So my first group, pull out a t. I'm left with 4t minus 9. My second group, pull out a negative something, 4. And I'm left with 4t minus 9. So did grouping work? Of course it did. If you find the two numbers, grouping should work. 4t minus 9 is the first term, like you're pulling that out in front, and you're left with t minus 4. If you guys are good and fine with guessing and checking, by all means, stick with it. You don't have to do this. This is just like that backup option for people that don't really do so well with that. So now when I tee it up, I get t equals 9/4 or t equals 4. And that means this is happening after 2.25 hours or 4 hours. Whenever we're solving an advanced type of function, anything other than a linear or quadratic, we need to check for what? Extraneous. You're not really checking for accuracy at this point. You're checking for extraneous. So if I plug in 4, what's the square root of 4? 2 minus 2 times 4 would be minus 8 plus 6. Does that equal 0? Does it? Yes, so that works. And if I plug in 9/4, what's the square root of 9/4? 3 over 2. Very good, because the square root of 9 is 3, square root of 4 is 2, so 3/2. Minus 2 times 9/4 is 18/4 plus 6. So you could just do that on your calculator. That's 3/2 minus 4.5 plus 6. 3/2 is just 1.5. So 1.5 minus 4.5 plus 6. Is that 0? No. 4 hours. Good? Now, you can't use your calculator to solve it, but you can certainly use your calculator to check. So if I were to type in this original function, the square root of x minus 2x plus 6, and my window, my t is time in hours, so I'm going to go 0 to 10 hours, and my y is the speed of the tidal wave, which I don't really know what that might be. I'm going to go up to 100 just for fun. Oh, perfect. That was way too far, by the way. I'll go 0 to 20. There's the speed of my tidal wave. And so you could double check that it's actually hitting a speed of 0 after 4 hours. Second trace. If you want to do value, you can, if you already were just checking if 4 was actually correct, 40 is correct. Okay? The second part, how much faster was the tidal wave traveling after 1 hour than 3 hours? So you want to calculate the speed at 1 hour, calculate the speed at 3 hours, and come up with the difference, right? So the speed at 1 hour is just going to be root 1 minus 2 times 1 plus 6. And the speed at 3 hours is just going to be root 3 minus 2 times 3 plus 6. This could be algebra 1. Okay? Your speed here is, and you would do this on your calculator, 1 minus 2 is negative 1 plus 6 is 5. And this one's going to be a little bit trickier. Well, the minus 6 and the plus 6 is going to cancel, so it's just going to be root 3 to the nearest mile per hour. So the square root of 3 is 1.7. So how much faster is it traveling 1 hour in versus 3 hours in? Just take the difference. And you get 3.3. What's the nearest mile per hour? 3. Wait. I remember this one. I remember Mrs. Hill and I both got this wrong because, look closely, you would lose a point for this. S is in hundreds of miles per hour. So this is 500 miles per hour. So S of 5 means 500 miles per hour. That 1.7 really means, move that decimal place over twice, that really means 173 miles per hour. Oh, we hated this. How silly. They do, in moments, try to trick you, and this would absolutely be one of them. So 500 minus 173 is 327 miles per hour. Whew, think tidal waves. They move faster than 1 mile per hour, right? That's like a disastrous scene. So if your context helps you pick up on something might not be right, that's helpful. Otherwise,